everyone, just a little review to talk about activities 28 and 29, which is what our quiz was over a few weeks ago, just to freshen up on some things. We began the unit talking about plotting points, and that particularly are polar coordinates of r comma theta. Now, polar coordinates, unlike rectangular x comma y coordinates that we're used to, have multiple points that are graphed on the same location. Because of that coterminal nature of theta, you can add or subtract 360 to it. Now, when it's a positive degree measure, that's when we're moving counterclockwise. Negative degree measure makes us move clockwise, very similar to our unit circle. There also is this feature with these polar coordinates that when our r value is negative, in order to make that back positive and a little bit easier for us to graph, talked about that you can either add or subtract 180 to that value, which makes it a little bit easier to graph. And adding and subtracting, usually it kind of depends on if you're between 0 and 360 to start, which one's more advantageous for you, but you could do either one officially. So looking at these couple examples that we have here, number one is at 315, so that's positive, so we're going counterclockwise. We have our point 3 units out, the r's for the radius, this would be 0.1. Point 2 then is with 2 negative 90, so we'd be going clockwise this time. 2 units out from our center, here's point number 2. And then last but not least, point number 3, to make that into a positive r value, again, we would want to add or subtract 180. In this case, I'm going to add 180 to 120, so we get 300 degrees, which would put us, if we go counterclockwise here at 300. Okay, and again, if it's already positive or negative and you want to just find another point that lies on that, feel free to just add or subtract 360 to that theta value as well to get the coterminal values as we have been for a while now. All right, now from there we talked about converting between forms. So if you are starting with your r and your theta, and you want to convert it back to our Cartesian rectangular format of x comma y, right, you would plug r and theta into r cosine theta and r sine theta to get your x and your y values. Now, if you're going the opposite direction, you have x and y, and you want r and theta, you're going to plug into r equals the square root of x squared plus y squared, and you're going to plug into tan inverse y over x to get your theta value. Now be careful of what quadrant you are in for that final theta value, because for instance, if we are at the point -3, 2, for an example, we're in quadrant 2, right? Left 3, up 2, we're in quadrant 2. So we need to make sure our final answer represents a theta value in quadrant 2. Now also be careful with the negative. When you're typing this in your calculator, make sure you're putting that -3 into parentheses when you square it, because otherwise it's going to affect your answer. Right? And then just be safe, parentheses 2. We have an r value of approximately 3.6. And then for theta, this is where, again, you also need to be careful because y divided by x, tan inverse, double check your degrees mode, and notice -33.7, that is a quadrant 4 value. We know -32 is in quadrant 2, so I'm going to add 180 degrees to this because now, 146.3, that is in fact in quadrant 2. So we have 3.6, 146.3 degrees as our conversion then into polars. Okay. Now another way of taking these answers, finding these answers, is if you do second button and then apps, you're going to get the angle menu, and then options 5 and 6 are going to allow you to take rectangulars to polars, 7 and 8 polar to rectangular. So again, if we look at that example that we just did, going rectangular to polar, we would select option 5 and then type in -3, 2. There's our r value, and then second apps, option 6, -3, 2. We get our theta value. Okay, so it's another way to double check yourself to make sure you are doing these correctly. Now, down below, couple more things. A reminder with circles. If you were centered at 0, 0, the rectangular form is just x squared plus y squared equals r squared. Polar form at 0, 0 is r equals a, where a is the radius length. Now, a reminder, as when you are not centered at 0, 0, then it goes back to our standard equation of a circle, x hikers. And when you are talking about polar conversion, if you have an endpoint of your diameter at 0, 0, then it's going to be a shift looking like one of these two equations below, whether it be on the x-axis or the y-axis. This time, though, the absolute value of a is going to equal the diameter. So it's a big change from when it's centered at 0, 0. Plus a shifts it right or up. Negative a shifts it left or down, depending, again, if it's a sine versus cosine. Other polar equations we talked about from there, though, involve either being a rose curve, if you have the format a cosine n theta, or a sine n theta, typo there, where n is not equal to 1, because if it was equal to 1, it would be a circle. Or you have your cardioid limicins, and that's going to be with a plus or minus format to them, and you're looking at your A and your B values. All right, remember, cardioids resemble hearts. Hearts mean you love each other. You're perfect matches, so A equals B. So where your limicins are going to have either a loop-de-loop or a dimpled effect to them, similar kind of to a cardioid if they're dimpled, but A does not equal B for those. So you can tell the difference between their formulas. Now, last but not least, one of the big things we talked about was converting between the forms of our equation. So again, this goes back to that fact that x equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared, or r equals square root of x squared plus y squared. But this is more useful to us for this format. So if we are given some examples here, we have the value here for polar and we want to convert it to rectangular. For an example like this, we're going to start by multiplying everything by an r, because when we do this, if we have everything as an r value, or with an r, we can make those conversions that we need to, right, from up above. So we can take our cosine theta and substitute in an x, our sine theta gets a y, r squared gets x squared plus y squared. So all that gets brought in. Now the other thing we are able to do is bring all of this over to one side. So I'm going to subtract that 9x over, and I'm going to add this 8y that we now have over. And notice now this is the beginning of looking like an equation of a circle. So we can complete the square on the left-hand side in order to add values to the right-hand side. Now a reminder, when completing the square, you're going to take your b values, divide them by 2, and square them. So negative 9 divided by 2 is negative 4.5. Squared, it's going to be 20.25. Oh. 0.25, and then 8 divided by 2 is 4. 4 squared is 16. And what we add to the left, we are also going to add to the right. Now factor the left-hand side. Reminder, shortcut is whatever you got when you divided by 2 is going to be your value inside parentheses. 5 plus 4 quantity squared. And when you add these together, we get 36.25. And here is our converted equation of a circle, right, to rectangular form. Now the next one is a little bit simpler, because notice x squared plus y squared, we're going to make that substitution in for r squared, square root both sides, and notice we have the equation of a circle in the polar format. And a nice quick conversion, because we know that if it's centered at 0, 0, like number 2 is, notice x squared plus y squared means it's centered at 0, 0 equals r squared. Well, to convert it to polar formatting, if it's at 0, 0, we know it's just r equals that radius value. Okay? There's a little work behind it. Now going from rectangular to polars, this is where, again, we're going back up here to the top and using these x and y values to our advantage, because we're going to start by plugging in for x, our cosine theta, and for y, our sine theta. And from here, we're going to take out that GCF between them of r on this left-hand side. So we can factor out r, and we are left then with 5 cosine theta minus 2 sine theta equals 13. Last but not least, when we get something into polar formatting, our goal is to get r by itself. So what we're going to do is we're going to take that 13 and divide it by all that stuff on the left-hand side that was in parentheses, so that we get our final answer, this line. Last but not least, the final example for converting that you are going to see is equations like number 4. Now notice this 2x squared is going to throw things off a little bit. And we're going to start this by adjusting this so that it is x squared plus x squared as opposed to 2x squared. Okay. The reason we're going to do that, and I'm going to write this a little out of order now, but that's okay, is because now we can, going back up to the top, convert in this r squared equals x squared plus y squared. We can take x squared plus y squared and make that r squared. Now we still have this plus x squared minus 8y. But something else that we're able to do is, as we're converting through, start plugging in for x, our cosine theta, and for y, our sine theta. Now notice we had x squared here, so it's still our cosine theta quantity squared down there. Now, as we start simplifying here, what we're going to do is we have r squared plus r squared cosine squared, distribute the squared, and I'm going to move the 8r sine theta over to the right-hand side. And keep all the r squared on one side by themselves. And again, we have these r squared in common as a greatest common factor. So if we factor those out, what we're going to notice is we can cancel one of those r squareds on the left with r on the right. And finally, to get r completely by itself, we can take the value that we have in the parentheses and divide it over to the other side, thus giving us our final answer. Okay. A couple other things to note that are not on the sheet. Reminder that your calculator to graph should be in degree mode and polar mode, so that when you go into the y equals menu, you can start typing some values in. For instance, if we want to look at a rose curve like this, we say maybe 3 theta, a rose curve here, and I'm just going to hit zoom 6, and we can see our rose curve there. Your table, hit second window to double check your table. You should start at 0, probably go up by 15s or 30s, so that when you look at the table, you can actually plot points more exactly for a better fit of your graphs. Otherwise, that's pretty much what all I have for us when it comes to polars and plotting and converting and all that. Any other questions, make sure you guys let me know.